So we start with our first chapter, that is electrostatics, the first unit. First we revise some topics of class 9th and 10th, and we start with the definition of electric charge. The first definition of electric charge was given 2500 years back by Thales. The definition says that when two bodies are rubbed together, they acquire the property to attract small particles like dry leaves. Such bodies are called charged bodies, and this process is called charging process, and the cause of charging is called charge. So according to the old definition, what is charge? It is cause of charging, because at that point of time the cause was unknown. Thales observed that when two bodies are rubbed with each other, they start attracting dry leaves and small pieces of paper and etc. Why the bodies are doing such thing, why they are showing such behavior, that was unknown. So the cause of charging, the process was named as charging process, and the cause was called charge. Then in the year 1600, Dr. Gilbert started experimenting with the same concept. In the experiment, four objects were taken: glass rod, silk, ebonite rod, cat fur. Glass rod was rubbed with silk, so glass rod became charged. Ebonite rod was also rubbed with cat fur. Ebonite rod also became charged and started attracting small particles. Dr. Gilbert observed that two glass rods after charging repel each other. Two ebonite rods after charging repel each other. One glass and one ebonite rod after charging, if they are brought closer, they show the phenomenon of attraction. They attract each other. This was a simple experiment, but two conclusions were drawn. A new thing was discovered about charges. The first thing is that charges are of two types. This is the first conclusion. Charges are of two types. Number one, vitreous. Vitreous is a charge which is developed on glass rod when it is rubbed with silk. The name was given because of the shine and smoothness of glass. The second name was given by Dr. Gilbert is resinous. Resinous is a charge developed on ebonite rod when it is rubbed with cat fur. Ebonite is a sort of resin, so the name resinous was given. The names positive and negative were given by Dr. Benjamin Franklin. So vitreous became positive and resinous became negative. So glass rod, which is positively charged, two positive charge repel, two negative charges also repel. One positive, one negative. Glass rod acquires positive, ebonite requires negative. They show phenomenon of attraction. They attract each other. So the second conclusion was that like charges repel and unlike attract each other. In 19th century, after discovery of electron, a new theory came into action. That theory is called electronic theory of charging. The first point is that electrons are responsible for the processes of charging. Now we know that there are several processes of charging, three main processes: charging by friction, charging by conduction, and charging by induction. After discovery of electron, it was found that electron is the particle which is responsible for all type of charging processes. And what electron is doing during any charging process, electron goes from one body to the other. It gets transferred from one body to the other. The body that gains electron becomes negatively charged, because electron is a negatively charged particle. If there are extra electron on a body, gain of electron, the body will show negative charge. Loss or shortage of electron results in the production of positive charge. When electron go out from body, the effect of proton increases and the body becomes positively charged. So now, when the glass rod is rubbed with silk, electrons go from glass to silk, because loss of electron produces positive charge. Positive charge. Glass rod is acquiring positive charge, so it is losing electron. So electrons are getting transferred from glass to silk. Similarly, when ebonite rod is rubbed with cat fur, electrons get transferred from cat fur to ebonite. So cat fur acquires positive charge and ebonite acquires negative charge. Cation, positive ion. The charge on the cat fur is positive. With electronic theory of charging, when we know that the electrons are getting transferred from one body to the other, electrons cannot be transferred in fractions. Either one electron will go from one body to the other, or two electrons will go from, or three or four, but 3.5 electrons cannot be transferred from one body to the other. So uh, another principle which is also related to electronic theory of charging is called quantization of charge. Quantum means packet, that is packetization or quantization. Charge travels in form of small packets or bundles, and one packet is one electron. Charge on any isolated body is always a whole number multiple of electronic charge. Charge on isolated body. The word isolated is very important, because if the bodies are connected, the quantization principle is not applicable. For example, on HCl molecule, because of shifting of electron pair towards chlorine or chloride ion, which is more electronegative, chlorine acquires a slightly negative charge and hydrogen acquires slightly positive charge. That charge is not whole number multiple of electronic charge, because uh, in HCl molecule there is no transfer of electron, it is only shifting of electron from hydrogen towards chlorine. So the principle is applicable for isolated bodies and not for connected bodies. Now, if we are charging a body and one electron goes from or comes to the body, or it goes away from the body, the charge on the body will be 1 into E. Q is the symbol of charge. E is charge of one electron. So charge will be equal to 1 time the charge of electron. If two electrons are getting transferred from the body or to the body, the charge will be equal to 2E. If three electrons, and so on, 3E and 4E. So the general formula is Q equal to plus minus NE. N number of electrons getting transferred from the body or getting transferred to the body. N is always a whole number. In the formula, we use both signs, positive and negative, but while doing numericals, if a body is positively charged, or if there is gain of electron, there is loss of electron, we take positive charge. If the body is negatively charged or there are excess of electron, we use only the negative sign. So plus minus, both signs are there in the expression, but while doing numericals, we will use either positive sign or negative sign. Now, when glass rod acquires positive charge, same amount of negative charge is developed on silk, because electrons are getting transferred from glass to silk. When ebonite rod is acquiring negative charge, same amount of positive charge will appear on cat fur, because electrons are getting transferred from cat fur to ebonite. So the next topic is principle of conservation of charge, which says that charge can neither be created nor can it be destroyed, but can only be transferred from one body to the other. There are three conservation principles: principle of conservation of mass or law of conservation of mass, which is now obsolete. Mass can be created, mass can be destroyed. There is Einstein's theory, E equal to delta m into c square, where delta m is mass destroyed or energy destroyed or energy created. Mass and energy can be converted. Mass can be converted into energy, energy can be converted into mass. The second conservation law is law of conservation of energy, but new nuclear reactions, that law has also become obsolete. But law of conservation of charge is a separate law it is not related to law of conservation of mass. If we say that uh, electron cannot be created, that is why charge cannot be created, then this statement is incorrect, because electron can be created in some reactions. The process is called the process of pair production. When gamma rays are stopped by an obstacle or a heavy nucleus, then the energy of gamma rays gets converted into electron. But automatically another particle which is similar to electron but it is positively charged, same another particle will be created automatically. The process is called pair production. Whenever electron, we try to create electron by converting energy into matter, then automatically another particle which is called positron will be created. So electron can be created but charge cannot be created. Law of conservation of charge is a separate law. It is not related to law of conservation of mass. Positron is also called anti-electron. Now, why it is called anti-electron? Because when positron and electron come into contact with each other, or they interact with each other, they destroy each other and again get converted into energy. The process of destruction of electron and positron and getting matter getting converted into energy, this process is known as pair annihilation. So we will start with Coulomb's law in the next video. Just listen to this video and try to understand, revise the basic concept and understand the basic laws related to electric charge. Good night. Thank you so much.